All right, welcome back to another Roblox programming tutorial. We are on the third iteration of our object-oriented programming series here, talking about objects in the Lua language. I will probably even make another video after this one discussing collection service because I still want to keep these short and concise. But in this video, we're going to talk about the four principles that are most commonly talked about when thinking about object-oriented programming. And we're going to go ahead and list those four principles now. So the four main principles when it comes to object-oriented programming are first going to be inheritance. It's a very, very important one. Then abstraction. Then polymorphism. And then encapsulation. So these are the reasons, and hopefully, mind my spelling. I am not sure I spelled any of these correctly. I just know I said them correctly. But these four principles are essentially why you should use object-oriented programming when doing stuff and what makes it so incredible. And, this is one of the reasons why it was invented, was because of these principles and concepts. So the first two I'm just going to look at is the idea first off of encapsulation. Now, encapsulation essentially says keep all your code in one place, meaning if you have an account class, right? So here's our account class. I define what a new account looks like and what it needs. And here's what it looks like and what it needs. And I go ahead and pass self here. Right? And then I describe all the things about self. So it instantly knows here that when I call this, I need to pass $100 and this string here because it needs the initial amount, right? And everything about the account is listed in the account class, right? I don't have any of these methods, I didn't write this method down here and paste it here, right? That doesn't really help. And as you can see, my text editor is why did you do that, right? Encapsulation essentially means keep all your code organized and in one place. And just like I tell my students, when you get ready for school or you get ready for work, you want to keep, your clothes in your closet. You don't want your shoes outside and then your shirt in your mom's room and your pants in the bedroom, unless you're me because I can't keep anything organized. But generally, you want to keep everything in one place. And that is the whole concept of encapsulation. Also, with encapsulation, you keep code pretty dry, meaning dry means don't repeat yourself. But when things are organized and concise like this, it's very easy for people just to reuse code and to just grab it. And they know exactly where it is because it's all encapsulated in one place. You have one class that defines what an account is, and you can call that class and use it. And that's what makes encapsulation so effective and clean. The next concept here is the idea of abstraction. So you all actually know what abstraction is, and I actually don't really have to tell you. Abstraction is the idea that you don't need to know everything about an application in order to use the application. And even me using the Roblox game engine right now is an example of abstraction. I don't need to know what Roblox headquarters, programmed in C++ when I click run here. I don't need to know all the source code, and I definitely don't need access to it all. I don't need access to their, int or whatever, main, their public static main and function or whatever it is, right? And then, I run that, and then I, include their std stuff, some C++ jargon there. But I don't need access to all of that source code simply to run this in Roblox Studio. All I need is just the ability to click run. Similarly, people don't need access to my class here, don't need to really mess with this source code here in order to run any of this stuff. All they need to do is type in this and know that they have to pass two parameters. So for example, local new vector is a vector3.new. I didn't make this vector3 class, right? I didn't make this. I don't know what they're doing on the back end of this. I have no idea what Roblox Studio programmed for this. I can guess, but I didn't make this. All I know is I just need to put in 3 numbers and it represents a vector in the game. That's it. That's all I need to know. And it even tells you returns a vector, right? This is the idea of abstraction, right? And I'll even show you guys another example. I don't need to know all the source code behind the Riot client launcher to launch Valorant, right? I just click on it and click Valorant and I click play and it runs, right? Very similarly, I don't need to know every ingredient in a cup of coffee in order to drink the coffee, right? I just drink the coffee. And it's the exact same idea here. And this is another thing that makes object-oriented programming super duper 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 effective and great, is the fact that you don't need, you don't need access to hundreds and hundreds and hundreds of lines of code just to run something simple. You can just type in the small little things that you need to put in to run it, and it runs. And that's a super, super, super good, important point to talk about. So that's abstraction and encapsulation. Now, the next one we're going to look at here is going to be the idea of inheritance. And this is a really, really good one to know. Now, I will note that I like, and I'll even put this here, I'm a fan of component structures. Component, can't spell anything. I don't know how to spell component today, it's that late. But I am a super big fan of component structures over inheritance, but inheritance has its place, and I'm going to go ahead and show you guys why. So let's go ahead and look at what inheritance is. Inheritance is the idea that a class, for example, accounts or whatever, can grab properties and methods from other classes. So to do this, I'm going to go ahead and use object-oriented programming to make a kill block. Okay, so I'm going to create a kill block here. And we're going to define what kill block new is. So kill block new is going to be a function. That function won't pass anything. We won't pass anything. And instead of self being an empty table here, we're actually going to go ahead and have the kill block class inherit from a part, since parts are kill blocks, right? So I'm going to do an instance.new of a part. Now, everything that I type in here about self, right, is going to essentially, here, I'm just going to get rid of all of this. Everything I type in about self here is all going to inherit from the part class, right? And you can even see this when you create a part. For example, here's our part here. I'm going to go ahead and delete this script. Hopefully, this is not the script I'm editing. But as you can see, here's this part. And all of this stuff here in the properties tab are all just, object-oriented stuff, right? For example, when I type in self before and I was doing like self dot, balance when I was talking about account balance, right? All of these things are things that I can manipulate and control when I do this stuff, right? So all I would do here is, do self dot anchored is true, and as you can tell, my IntelliSense in Studio is picking all of this up. I want the can collide to be true. I can now set the self.color to red by doing a color3.new here, and doing 1 here for the color. We could just comment 0.0 just to keep things nice and concise. Self.parent is going to be the workspace. Right, you can also do self. You have all these things like the transparency, the mask. You could essentially treat this just like a normal part, right? And per normal, we'll go ahead and do the famous kill block stuff. If you don't know how to do a kill block in Roblox Studio, you can go ahead and watch one of my videos on it. However, I really don't think you should be watching this one if you don't know how to make a kill block. Equals t.parents. It's probably better that I call this touched. Get out of the habit of naming things not well. Touched dot parent colon find first child humanoid. If humanoid, then humanoid take damage. We'll put in 100 here. Right, but as you can see, I can create like new properties and new things that can essentially be stored and manipulated into this part table. So what this is doing is this is taking all the stuff from part here and it's putting it in here, right? And it's manipulating all these things. And this will, in return, act exactly like a kill block. And we can go ahead and see this now. I'm going to go ahead and parent this to this part here and go ahead and do our local part is equal to the script dot parent, and then we're going to do, we should probably pass the instance that we want to be a part here, so I'll call parts here instead, and we'll just go ahead and say you have to pass in the parts here. That way it knows what needs to be passed. It's going to be that part, and then we're just going to do kill block dot new, and we're going to pass the part that is the script parent. As you can see, you can also create a new instance of a kill block that inherits from parts. This will essentially do all the same thing. I'm just doing this as just a more concrete example, right? But here's that part, right? I'm gonna go ahead and move that over here, kind of put that right there. And as you can see, when I run my game, it turns right into a kill block. So if I go ahead and jump on this, I pass away. And that is really the idea of inheritance here, because all I did was I took the part, class here, and I essentially inherited all of its things and then added more, methods and functionality to it. And you can, do all the part manipulation that we've seen so far in this course, but this is a much better structure. And as you've probably guessed, when we start getting more into module scripts and we call stuff in, this really, really, really becomes an incredibly powerful way to organize code. And, as you can see here, this is the whole idea behind object-oriented programming, is everything is very nice, neat, concise, and organized. And at any given moment in time, if I need to see what the kill block script is or what's wrong with it, I instantly go to the killblock.new function and I can instantly see everything about it. And if I want to change anything about it, it's all right here. So that's another video on object-oriented programming, guys. Here are the 4 main principles we covered today. Inheritance is the idea that you can have objects like a kill block inherit from another class or a base class. In this case, it was the class part, which is right here. Abstraction is the idea that you have all your code, that you don't need access to the source code here to make a kill block, right? And the example of that was when I did vector 3. Right, when I did a new vector3.new here, I didn't need access to all the source code that creates a new vector3 in Roblox Studio. I don't need access to that C++ code to do this, right? I can just type this in and I can use this and assign it and do things with it. The same way that I kind of did this, right? And I can even go, local new kill block. And I can set that equal to that. Right, and I can even start altering things about this, but I can create a new kill block here and I don't need access. I have it, but I don't need access to all this code here, right? And that is the idea of abstraction. This is an abstraction of all of this. Polymorphism, we didn't cover this one, we'll cover this in a second. And encapsulation is the idea, again, that you keep all your code in one place. So before we head out here, let's go ahead and look at what polymorphism is. Polymorphism is the idea that depending on the object or data that you are working with, specific behaviors change, right? And I can go ahead and use an object-oriented programming setup to show this, but instead of that, I'm going to show a much simpler way of doing this. So let's go ahead and say I have a local class here and we'll call this calculator, right? And I'm going to go ahead and do calc.new, and I'm going to set this equal to a function. Okay, and this function is going to go ahead and have a local self variable here. I'm going to go ahead and set an empty table here. And this is going to go ahead and return the self variable. And it's complaining here. Function. Why are we complaining? Oh, whoops. No parentheses here. My mistake. Okay. All right. So let's go ahead and say that this calculator adds. So we're going to do calc.add. And then when we call the calc.add method from the calculator class, it's going to take 2 numbers, as it should. So we'll call this, num1 and then num2. We're going to go ahead and end here, and then we're going to go ahead and do print num1 and num2. All right, so let's go ahead and see here. So if I go ahead and do new calculator is equal to calc.new, and I do calc calc.add, and go ahead and add two numbers together. So let's say 10 and 20. Okay. All right. So I'm going to go ahead and run this here, and you will see here in my little thing, it will go ahead and print the addition of that. Whoops, what happened? Printed 10 and 20. My bad. Let's see here. Whoops, print num1 plus num2. My bad, guys. Oh, no. Plus. There we go. Cool. All right. There we go. Now it'll print, instead of printing both numbers, it'll go ahead and print num1 and num2, and that will be 30. Okay? So, notice here something really, really interesting. This addition here is only going to work when you have two numbers here. But what happens if I pass things that weren't numbers? What happens if I pass here 10 and 20? Right? I didn't change this at all. Right? I didn't change this at all. And I didn't really change, I changed this into strings, but as you can see here, the way this is going to work is it's not going to work at all, right? It's going to give me an error because I tried to add two strings together. And that is the idea here, is that based on the data or based on the specific method you were trying to do, the method can change based upon the data that's contained here, right? So normally you can add these two numbers together. However, you can't add them together in this instance because you have strings here, right? And I can even have this behave differently depending upon the parameters that it takes, right? So I can have, this behave in a completely different way depending upon this. And that is the idea of polymorphism, is that different classes and different objects will behave in a different way based upon the data they contain. And it's a super important one because sometimes you'll be extending classes and you'll be inheriting from another class and doing things, right? And you'll realize that, certain functions will get overridden by other functions and certain things will happen, and, things won't behave the same, even though that you were typing in here, calc.add. It didn't add these two things because the data contained here was not the correct data type, right? Now, I could have this behave differently, but it's two dots here. Notice that none of this changed here, but if I change this here, it's going to behave differently, and it actually puts the two things together here in that way, right? So this is, again, another instance of polymorphism where the behavior of this class changes based upon this data. Okay, so I hope this video was helpful. This is a really, really good example and some of the fundamental, again, core concepts of object-oriented programming. I recommend that you really get good at this, guys, because object-oriented programming is so fundamental and so important. So if you have any questions, please feel free to leave them in the comments, and I will see you all in the next one.